Look up, tune in, the night is calling you. Planets, comets, moon and stars, there's always something new. From stargazing to science, we'll guide you through the sky. With the ALPO family, reaching higher, looking high. So grab your scope, your notes, your dreams, let curiosity unlock it. You're listening now to the one and only Observer's Notebook Podcast.
Hi, everyone, and welcome to the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Each episode, we share their latest discoveries, observing techniques, and stories from the people who explore the moon, planets, comets, and beyond. Whether you're looking through your backyard telescope or leading professional research, we are all united under one sky. I'm your host, Tim Robertson. Thanks for being here. Now, if you usually listen to the podcast in your car or on your phone, you can now watch it too? That's right. The Observer's Notebook is available in video right here on the ALPO YouTube channel. And here's another interesting fact. Over 70% of the people watching or listening are not subscribed to the podcast. So take a quick second, hit that subscribe button, and ring that bell so you don't miss another episode. It's free, and it really helps grow the channel. This show is made possible from support from you, our listeners. If you'd like to help the Observer's Notebook, you can check out our Patreon page. Just go to www.patreon.com/observersnotebook. And for $1 a month, you're supporting the show. For $5, you get early access to new episodes. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you'll be listed as a producer of the podcast. And of course, to learn more about the ALPO, you visit us at www.alpo-astronomy.org, where you can join the organization for as little as $22 a year. And now get started with episode 240, and we're going to talk about exoplanets and SETI right here on the ALPO podcast. Enjoy. Are we alone in the universe? For centuries, humans have looked up at the night sky and wondered if somewhere out there another civilization is doing the exact same thing, looking back toward us. Today's guest is leading that search. Joining us is Franck Marchis, astronomer, planetary scientist, entrepreneur, and one of the leading voices of modern SETI research. Franck is also known for his groundbreaking work in adaptive optics, asteroid systems, exoplanets, the search for technosignatures, which I'm sure he'll explain what that is, possible evidence of advanced civilizations elsewhere in the cosmos. He's also deeply involved in the future of astronomy through innovative telescope networks, citizen science, and the development of new observational technologies that could dramatically expand our ability to detect life beyond Earth. I think this is going to be a pretty exciting conversation. Welcome to the podcast, Frank.
Thank you very much for having me, Tim.
Yeah. Before we get started, I'd like to know what first inspired your interest in astronomy?
Oh, that's a very good question. Probably, I like astronomy because I always thought it was kind of the poetry of science. It's basically a field where you can ask big questions, questions which has an impact on humanity. I mean, I could have been a biologist and cure sickness or mathematicians, but I think astronomy had this kind of great relationship with humanity at large, with our civilization, how we evolved, where we're coming from. And that's one of the reasons I was very interested by this field early on. Okay. And in fact, when I was 17, I wrote an essay talking about SETI and how SETI is something that we should invest more time and money.
Wow. So did you always envision working on the search for extraterrestrial life?
I was a dream as a young student in high school in France, in the south of France. I grew up in Toulouse, which is the aerospace capital of France. I saw astronauts. I met Hubert Reeve. If you are Francophone, you know that Hubert Reeve was kind of the Carl Sagan of my generation in France. And so I learned about astronomy by going to events. And having my parents that brought me to see for the first time a lunar eclipse, for instance. That's a memory I have when I was 6 years old.
Oh, very good. So your career spans planetary science, exoplanets, and doing instrumentation as well. How did that lead towards SETI?
So one of the issue with SETI, when I started being very interesting as a scientist with SETI, I didn't want to do radio astronomy. I mean, radio astronomy is great,
Hmm.
it's valuable,
Mm-hmm.
but that was not something that really interested me. I wanted to do image processing and improving image quality of telescopes because my goal at the time was to be able to create an instrument that will be able to image another pale blue dot.
Okay.
That's my link with SETI. Really building instruments that will allow to see a planet like Earth. Because I believe that this will change the way we see our place in the universe and will bring a lot of information about our own planetary system, but also maybe see life over there.
Huh. Yeah, when most people think of SETI, they think of these huge dishes and
Yeah.
Jodie Foster sitting on the hood of her car, listening to noise. So what is SETI today?
SETI today is a lot of things. SETI is, there is three ways. We talk about that often. One simple way is to look for life in our solar system. So that's why we are building rovers and um, new type of submarine-like instrument to explore the ocean of Europa or the surface of Mars or analyze the particles in the geysers of Enceladus. These will probably not, we will not find intelligent life on Mars, I'm pretty sure. We will find
Hmm.
microbiological life, but you will never know.
Right.
Maybe nature is more imaginative that I am, and maybe there is or there were intelligent life on Mars, for instance.
Hmm.
That's the first way. The second way at SETI is kind of a race, a friendly race between scientists. We generally choose one path. So the path I chose initially was to image exoplanets because we quickly discovered that around each star in our galaxy there is two exoplanets in average, and there is 3 millions of those exoplanets at least
Wow.
that could have potential could be potentially habitable, meaning similar in size to Earth and located in the habitable zone of the star. So that's a lot of worlds we can explore and a lot of worlds where we could find life. Then, so this was basically the path I chose at the beginning
Right.
because I was building instruments, adaptive optic systems for to image exoplanets, and the goal was really to be able to image Earth-like exoplanets. But then the reality is that to achieve that, it will take times, it will take a lot of money,
Mm-hmm.
building bigger and bigger telescope. JWST took most of the budget of astrophysics for 10, 15 years. And there was no a lot there were not a lot of development in this area. So I decided to move more into small decentralized telescopes and instruments, small instruments capable of doing SETI. And that's the reason I moved toward Laser SETI and Skymapper, which are two projects which I believe will be able to detect and the existence of life in our galaxy.
Hmm. Now, I mentioned the word technosignatures earlier. Can you just explain briefly what that is?
Yeah. So technosignatures is simply we basically think that if a civilization is similar to our, meaning it's biological and technological and intelligent, they have been building things. So that maybe they build radar, maybe they have their own TikTok, maybe
Hmm.
they have powerful lasers, and they spread across the galaxy if they're
Okay.
more advanced. So if an intelligent technological civilization is here, we could detect the signature of this technology. That's a technosignature.
Okay.
So it could be powerful lasers, it could be radio emission, it could be something we don't know yet about, like quantum entanglement signals or something like this. So there is a lot of potential here. And when we do SETI at the moment, people should understand that we are searching life like technology like ours. If there is a intelligent species that live in full harmony on its planet, meaning that they don't need to have technology. They may be like whales, in super intelligent whales, for instance. They don't need to build anything.
Hmm.
They will not be detectable. They will be quiet for us. We are searching the life like ours.
Okay. Interesting. Recently, it seems like the scientific community has been more open to SETI research. Are you seeing that as well?
Yeah, of course. When I started my PhD in 1996, people were making fun of those tinfoil scientists doing SETI.
Hmm.
I heard multiple of my colleagues, especially European, making fun of those
Hmm.
researchers. When I arrived at UC Berkeley um, in the US, yes, SETI was not that far away. We almost had no relationship with the SETI Institute, even though there was cutting edge scientists working there,
Hmm.
because the UC system did not really like at the time SETI researcher. It was not considered to be real science. Plus, there was no funding, and you know how science is led by is by science
Yes,
funding, in
that's
fact.
right.
So it's only, I would say, 10, 12 years ago that SETI become mainstream.
Okay.
And there is principal reasons for that.
Yeah.
Uh, One of them is because we talk more and more about extraterrestrial intelligence, because we have instruments which are better now. We're starting seeing exoplanets. Um, we're starting detecting, analyzing the atmosphere of Earth-like exoplanets, like TRAPPIST-1 using JWST. So there is more kind of activity related to the search for life in our galaxy. And the extension here is the search for intelligence life comes very quickly. That's why SETI is becoming mainstream.
Yeah, the exoplanet boom going on right now too is I'm sure has had a direct effect with SETI as well. I mean, now
Yeah,
we're seeing these planets out there, and now we're okay. Can these are these habitable planets?
yeah, we are seeing, we're detecting them. We're seeing more of them. We give them names, and that's a big impact in the psyche of civilization.
Hmm.
We kind of take ownership of those. Young people now, they grew up thinking that the galaxy is teeming with exoplanets. You and me, we probably remember when they discovered 51 Peg
Hmm.
or others, where there was still a huge argument for 2 or 3 years about if that's truly an exoplanet
Right.
or some kind of random signals. So now, young people, young astronomers, the one who have a PhD now, they grew up with the existence of exoplanet. They know there is exoplanet, habitable exoplanet, probably. So yeah, probably there is life.
Yeah, I was recently at the AAS conference in Phoenix, and there's thousands of students there, and they all came by our booth, and I asked them all what they were interested in. I would say 99.9 out of 100, the word exoplanet came out of their mouth.
Yeah.
That's their field of study right there. Are there any exoplanets out there that you are especially intrigued by?
K218b.
Yeah.
I mean, everybody is intrigued by this one, right? I'm sure you are too.
Hmm.
Uh, Potentially an ICN planet, meaning a planet like size of Earth, covered with an ocean. Um, and we have some interesting detection of a potentially complex molecules. Dimethyl sulfide is one of them. And if that's truly confirmed, that was done by using JWST by transit with two different type of instruments. If this is confirmed, this could be the first detection of biological activity on an exoplanet. And as extraordinary claims requires extraordinary evidence, of course. So we are not there yet. I mean, this is a very spurious detection. It's been coming from two different instruments. Dimethyl sulfide has been detected around comets, and they don't have life. So I don't think we can say that this is a ultimate proof of existence of life. But that's a very interesting planet. And what is important here is that we are capable of detecting signatures of biological activity on a planet that far away by transit using this kind of instrument like JWST. So it's remarkable to me.
So we're just now detecting true biosignatures.
We have the potential to detect true
Okay.
biosignature.
Okay.
I will not say that this is a true
Okay.
biosignature, because then you're going to receive a lot of emails from my colleagues saying, don't invite this guy ever again. But it's a signal that could be a biological signature. And that's the beginning. I mean, when there is one, there will be multiple of them. There will be other coming soon.
So what is it, advancement of telescopes that will lead to that we need bigger, better telescopes in order to detect this?
Yeah, we need always bigger telescopes, right? That's the conclusion of every talks. But more data, bigger telescopes, but also being smarter and being build better instruments. The ELT, the extremely large telescope that we are building now in Chile, is a 45, 42-meter telescope, depending of how you consider the aperture, is going to be able, theoretically, to detect in the mid-infrared planet like Earth in orbit around Alpha Centauri. If you observe long enough with an adaptive optic system and a coronagraph, if you have excellent engineers, if the instruments behave as expected, and we point the telescope toward Alpha Centauri for, I think it's around 10, 15 hours, we should be able to detect a planet like Earth, Venus, or Mars. So if there is an habitable planet around one of those stars, we may be able to see it.
Wow. Now, with technology ever changing, AI, it seems to be transforming every field. How is it changing SETI?
It's helping us to analyze the data quicker.
Okay.
We basically now, with AI, capable of getting almost in real time the the signal, a technosignature in the radio collected by a radio telescope. Radio telescope collects terabytes of observation per night, and it's a lot of data. And it used to be that they were observing in the night or during the day, and they were copying the data on the hard disk, and then they put it on the server, and then find some time to analyze the data. And it will be taking like weeks sometimes, okay, or months. There is even papers published on data that was taken like 2 or 3 years later before that. So that was very tedious and complicated data analysis. SETI started a project with NVIDIA, and now we have this AI, basically algorithm, plug onto the AI chip, and it allows to analyze in real time radio signal coming from the ATA, the Allen Telescope Array, which is our radio telescope. And because of that, we can basically almost in a few minutes, that's the goal, get to confirmation of detection of the technosignatures. And this is important because remember, we have detecting things. Frank Drake mentioned it as well multiple times. We have detected signatures. Peter Ma published a paper in 2022 where we have 8 signatures coming, which are unexplained. And they're coming from archive data taken 6 years, 7 years ago using the Parkes telescope. Um, what we need for SETI is to detect the signature, make sure it's a real signal, so have an additional antenna that observe it later on or simultaneously, and then collect the data and do an analysis almost in real time. So now we are getting there. I'm not a radio astronomer, so I'm
Mm-hmm.
basically telling you what my colleagues told me. But I don't want to take credit for this remarkable work, but it's done by the SETI Institute, by the SETI team, led by Andrew Simeon. For exoplanets, we have developed algorithms that analyze data coming from the Kepler mission and now the TESS mission to detect these transiting exoplanets and do it quickly. And more importantly, have a very accurate estimate of the quality or the certainty of this observation. So this is done by AI algorithm. And then for the laser SETI stations, we are building as well an AI-based algorithm that will be able to detect a laser pulse coming from an advanced extraterrestrial civilization.
Wow.
So in short,
Oh, you're sideways. Oh, there you go.
I'm back. In short, it's probably an AI that will discover first
Yeah.
ET. It's not a human being.
So
The human will be there to confirm, but AI will find it first.
that makes sense because we collect more data than we can ever analyze on our own.
Exactly.
That's always been the problem with SETI too. You get all this data coming in, and good. I'm glad AI is a positive here.
Yes.
Yeah. Now, amateur astronomers and citizen science. I remember back years ago on my computer, I had SETI at home.
Hmm.
And that to me was one of the first citizen science things I was ever involved with. And so what are amateurs doing now? What can they do now to to be meaningful to SETI and exoplanet science?
So to be meaningful to SETI, I'm going to talk about what I do. There's
Okay.
a lot of things that they can do, like helping training AI algorithm using Zoo Universe and stuff like that. But at SETI right now, we are focusing more in making people skykeepers. We want people to share the sky, to share their instruments.
Okay.
So that's the reason we created Skymapper.
Hmm.
The idea here is that if you have a telescope, or if you want to share the sky, the entire sky above your house or your property, you purchase a device called the SkyReach. You plug it to the Wi-Fi of your house, and the Wi-Fi or you connect it to your telescope or your all sky camera, and the system basically is part of the Skymapper network. What it means is that someone, a human being, can take control of your telescope and observe. Can do that for fun, like observe a galaxy in the southern hemisphere, for instance. If you live in the northern hemisphere, they can make requests for observation. They're scientists and they're interested in monitoring the activity of a comet every day, for instance, or
Hmm.
follow up transient event detected by the Vera Rubin telescope. But they can also have their system part of a queue. So we have a queue, an AI queue that is collecting a lot of requests for observation coming from people or from machines. And we optimize with this queue how we're going to observe. And we task telescope to observe continuously objects or to work together to do observation of satellites, for instance. And the idea here is that using rotation of Earth and using the fact that we can connect thousands of telescopes, we'll be always able to see an object passing in the sky to confirm this existence. And you probably see where I'm going here.
Hmm.
SETI always been about detecting technology, right? Detecting laser pulse, detecting radio signals. We are now entering into the area of detecting the unknown. So UAPs is an example of the unknown. We don't know what those things are. There is most of the time rational explanations.
Mm-hmm.
So with these all sky cameras connected to our system, we can basically observe the entire sky all the time. And the data come to our servers. They stamp with a proof of observations. They immutable, they're on blockchain. So we know who took them, we know they have not been altered, and we know that this is a real observation, not taken by an AI or
Okay.
generated by an AI. Sorry. And that will make we will be able then to publish this result. So if we find UAPs or we find some weird phenomena in the sky, recording with this Skymapper network, we'll be able to share this data and we'll be certain that these observations are real observations. That's the new SETI
Okay.
to me. And this is the power of network. This is the idea that any of us can be citizen scientists. Any of us can share the sky and contribute to science. You can also write your own algorithm and have access to our database. And basically, if you think that
Oh,
you have a great idea or how we can detect UAPs, you can just go through our database, train your algorithm, and then run it onto our platform. So it will collect observation coming from all those telescopes and all sky camera and confirm the existence of UAPs or other things that interest you, auroras,
wow.
meteors, etc.
So how many people do you have in this network currently?
So right now we have 66 telescopes connected, and we have 6 Skysphere stations. The goal is to have by the end of the year 1,000 telescopes.
Oh my.
So that's mean we will be able to. You will connect on our platform, and there will be always a telescope available because there will be always dark somewhere and clear somewhere.
Mm-hmm.
So there will be a telescope available. And stations, we are aiming to have 5,000 of those stations all around the world in a year. For this, for the telescopes, we have an agreement with Unistellar. So we're gonna first start with connected unistellar telescopes. Those
Okay.
are digital smart telescopes,
Mm-hmm.
but more telescopes are going to join us. I can't say names yet, but you know there is not that many brands,
Mm-hmm.
and they will probably join this Skymapper network because it's a good way to make your telescope available to a community.
Mm-hmm.
And I forgot to mention that you earn token by making your telescope available. So you make money by sharing your sky.
Oh,
That's the key
really?
part here.
Oh,
Yes. So that's mean that after earning enough token, or you can buy another telescope. Or you can create your own mini network with your friends and family, for instance.
interesting.
And then to go back to the initial question, which I forgot, when we are going to have 5,000 units, all sky camera, you will be able to access to those observations. And we are developing products for this Skymapper network. So one of the first products we have is a drone detector. So you buy this instrument, it will acquire observations every 10 minutes, a few frames, but he also analyze continuously. And if there is a drone passing by above your house, you get an alert on your phone.
Really?
And that could be useful for a lot of reasons.
Oh yeah.
If you live in Latvia, I was there yesterday.
Mm,
That's very useful because there is drones coming from different parts of the world now.
right.
You know what's going on in the Middle East, for instance, as
Mm-hmm.
well. If you live in the US, insurance companies are using drones illegally to monitor properties in the countryside, for instance. Um, then we will have more products, maybe us, maybe other people, that to detect meteors. Scientists love those, and because Peter Jennings scan, for instance, at SETI Institute, if you detect a meteor using multiple stations like that by triangulation, you can derive the area of impact. So you go over there and you have fresh, pristine pieces of asteroid meteors, not yet altered. by water, for instance, if you're
Mm-hmm.
fast enough. So this is a kind of
Wow.
science which is very important for SETI scientists, for instance. So this project is not has so many applications that I can talk about it forever. But the
Mm-hmm.
main point here is is the fact that SETI is on board in building a decentralized network of telescope and all-sky camera. So we provide access to the sky to everybody.
That's fascinating. I'll put a link to the Skymapper in the show notes so everybody can go there and check it out. So, personally, do you believe there's intelligent life out there?
It's like asking a priest if he believes in God. Of course I do.
Okay.
That's my
So
motivation
that's your okay.
every
So
morning.
why do you think we haven't found definitive evidence yet? Is it just instrumentation?
Instrumentation, because when you think about it, we started emitting radio emission, I would say 60 years ago. Laser, powerful laser, I would say less than 5 years ago,
Mm-hmm.
and it's increasing now. Imagine what we'll be doing in 200 years. Maybe we have mastered something like quantum entanglement, and I will be talking to you living on Mars in real time because we have found a way to basically communicate through space and time using quantum mechanics. I'm making up a story here, but that's
Mm-hmm.
evolution, technological evolution
Right.
can go so fast and it's exponential now, and we see it with the AI, for instance, that to detect an advanced civilization, you need to be in this narrow moment where you can talk to each other. And if a civilization is 200 years more advanced than us, maybe they have a zero interest in communicating with us because
They're smart.
we ants, they're smart, we're dumb, they don't live in the same kind of continuum. I don't know what it is, but that's one of the reasons. The distance and the
Mhm.
synchronicity is key here. So to find life like us, which is what I was saying before, having the same evolution than us, close to us, is very difficult. And
Mhm.
we starting the search only 45 years ago. It's a very new field.
Right.
We have been listening how many star in radio continuously, less than a million. So we need to increase the search. We need to increase the number of instruments observing the sky and increase the capability of those AI algorithms. The Skymapper network, to go back to that, is exactly that. It's like broadening, making a continuous observation of all the sky all the time. And maybe one day we will find a UAP or
Mhm.
something that looks like an UAP and could be something that we cannot explain using our current physics. Is that an alien spacecraft visiting us? Maybe, maybe not. Maybe it's something else that we didn't even yet envision. So that's where we're going. We need to get more data and
Mhm.
observe more often, and more importantly, start developing algorithm with an open mindset.
So hypothetically, if a technosignature was discovered tomorrow, what would happen next?
You will have an announcement made by the head of the country where the signal was detected, and United Nations. This will be done after the scientist has confirmed that the signal is a real signal by asking colleagues around Earth to do the continuous observations. The signal will be available to everybody, so everybody can see, check it, the community of scientists and others, and the announcement will be made.
Would that
Everybody will be talking.
would that
Go ahead.
confirmation be suddenly, or would it take years?
It depends. If the radio signal, SETI is a little bit. SETI is a shortcut to do the search because it's a binary answer. It's
Mm.
yes or no. It's yes we find something or no we don't find anything. So if we find a technosignature, another instrument detected, and after a few days we still see it, and we see some variation which suggests that it's a signal, intelligent signal, we will make an announcement. If it's a trace of light of a city coming from an exoplanet located around a star 25 light years away from us, and the detection is marginal in the spectrum, it will take years
Mm.
for astronomers to agree on it. Okay, but that's the way science works.
You're right.
This is. But let's talk about the SETI scenario. If there is a detection, it's confirmed. We have seen it multiple times. The announcement is made. Is it going to change the world? I don't think so. I think we're already ready for it.
Mm.
Look at the news, look at the people, the way they talk about it. There are already some. I have so many friends who are 100% sure that there is life elsewhere already,
Yeah.
convinced by all of this. I'm just getting a message right now from a UFO on my phone. So you see, it does happen a lot, and it will not change the life of people right away, but it will change our perception of our place of the in this universe.
Hmm.
If we know there is another intelligence elsewhere, I think it could have a very positive impact on us. I believe that one of the reasons we are so agitated as a species and not very knowing what we want to do is because there is always this fear that we could disappear because we are an anomaly in the evolution of the biosphere. We have
Hmm.
taken a branch of evolution, and one day this branch will cut because intelligence, biological intelligence, is not stable. We we have to disappear. Earth will make us disappear because we are not supposed to be there for a long time. I'm talking about philosophical view here and
Hmm.
more like
Hmm.
evolution, biological evolution, because we're destroying the environment. We have an impact on this planet, etc. So after a while, this planet will react. The system itself will react and destroy us somehow. So if that's the case, we are basically an anomaly. But if we find another intelligence elsewhere, we suddenly realize that no, we have a future. And I think knowing that you have a future as a species, it's a gift that will make us a better species.
You have to be a very positive person to work in this field, don't you?
Yeah,
You
yes.
can't be an optimist. You got to be all in. I'm getting
Yeah,
that
you
from
have
this.
you have to believe in it. I
Yeah.
mean, you don't have to believe in aliens, but you have to believe that this will have
Yeah.
an impact, and ignore comments and
Hmm.
I mean,
Yeah.
yesterday, I went to a show about drones, and I met this person who totally makes fun of me because I'm searching for aliens. I let him. He
Yeah.
wanted to get the attention of people by making fun of someone who is doing a job that he cannot understand. I'm fine. Let it.
Yeah.
I let him do it. And
Yeah.
then after a while, I know that at the end, I'm doing something that is passion. Will have an impact on humanity,
Yeah.
and doesn't cost that much money. It's not. It's not like we are not seeking the budget of United States by looking for aliens.
Right. Right. Very good. Frank, this has been fascinating. I really appreciate it. Do you have anything else you'd like to share with our viewers?
No, I think one thing I want to share is that we, the SETI Institute, also have a very strong program for education and outreach. And the reason we are doing this is because all of this idea of searching for extraterrestrial life and technosignatures and so on is bringing a lot of people in the field of science, in the field of astronomy. So we are, yes, people can call us sometimes the tinfoil scientist, but we are an institution which has 3 million followers on social media. There is not that many. We are an institution that challenge sometimes the way people see the world and science. we also challenge other scientific institutions with our discoveries. So yeah, we are kind of the bad boy sometimes of science, but it's been rewarding. On a long Now we see we were right on a lot of things, like the existence of exoplanet, the existence of potentially habitable exoplanets.
Mhm.
So I'm very I really like the fact that we have a very strong support from people in general. People
Yeah.
know SETI, people love SETI, but also is engage with us, and that's good for science in general. So
Yeah.
that's the main point here.
And Hollywood loves you.
And Hollywood love us. And kids look at the star more often because
Yeah.
we make telescope for them
That's
as
right.
well.
That's right. Well, Franck, I really want to thank you for coming on the podcast today.
Thank you very much for having me. And yeah, let's continue this conversation in the future.
All right. Wow. That's going to wrap it up for this episode of the Observer's Notebook podcast. I really want to thank Franck Marchis for coming on the podcast today and giving us a really good discussion about the new SETI Institute and also the Skymapper program. I will put those links in the show notes. If you enjoyed this episode, please take a moment and give it a thumbs up. Subscribe and share the podcast. It really helps us reach more listeners. New episodes of the Observer's Notebook drop on the 1st and 15th of every month. You can also find us on iTunes, Spotify, and the ALPO YouTube channel. If you'd like to help support the podcast, you can do so through Patreon. You can start off with a few dollars a month. Up to $35 a month will receive exclusive benefits and a 1-year membership to the ALPO and producer credits right here on the show. So you find our Patreon link and our ALPO link in the show notes. And a special thank you, as always, to our producers, Steve Siedentop and Michael Moyer, for their generous support of the Observer's Notebook podcast. And if you'd like to get a hold of me, my email address is tim.robertson@alpo-astronomy.org. That's all for now. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this International Lunar and Planetary Astronomy Organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign-up screen. Gives you the information on the organization, and there's 2 ways to join. You can join by mail, where you will download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.